Alright, so we're going to use square roots to solve quadratics. This is an example where we can write it in x squared equals d, basically meaning that there is no bx in the middle. So we're going to look at this first one. I like to think of order of operations. They would have done, of course, to the exponent, they would have squared it, which is the good thing we're going to have to undo last. They would have then multiplied by 2, they would have subtracted 42, and they would have got 8. So we're going to reverse that. We're going to add 42 to both sides. That would leave me 2m squared equals 50. You're going to divide by 2 on both sides. That leaves you m squared equals 25. And then the way to undo a squared sign, of course, is to do the square root, and we'll do it to both sides. And we just need to remember that when we take a square root, your answers are positive and negative. Same on this one. In order of operations, they would have done the parentheses, so they would have added. Then they would have done their exponent. Then they would have taken it times 6. So the first thing we're going to do is we're going to divide by 6. That would leave me quantity x plus 4 squared equals 3. Now we're going to want to undo our exponent, so we will take the square root of both sides. That will leave me an x plus 4 on this side, and the square root of 3, which is 1.7 if we round it. And we have to remember that when we did that square root, we actually get a positive 1.7 or a negative 1.7. So when I go to undo the plus 4, I'll be subtracting 4, but I'll actually be subtracting 4 from positive 1.7, and I'll be subtracting 4 from negative 1.7. So I take 1.7 minus 4, and I get negative 2.3 for the first one. And I take negative 1.7 minus 4, and I get negative 5.7 for the second one. Those are your two zeros. And once again, if we remember what that means, those are the 2 points. Those are the 2 points that parabola will hit the x-axis, the 2 zeros, at negative 2.3, somewhere roughly in there, and negative 5.7, somewhere roughly over there.